Hello, Mr. Price here, and this is the fifth video on the January 2006 M2 paper, and this one is all on collisions. Let's take a look. So, we have three spheres, A, B and C, of equal radius and equal mass, and we know these masses, it's 3m, 2m and m respectively, and these are free to move on a straight line on the smooth horizontal table, and we know that sphere B and C is stationary, and sphere A is moving with a speed of 2 meters per second when it collides with sphere B. And we're told that the collision is perfectly elastic. Okay, so effectively our coefficient of restitution here is going to be 1. And for the first part of the question, we are being asked to find the velocities of A and B after the collision. So, as with all questions, we are going to model what's happening with the diagram. So, we have sphere A of 3m, and we know this is travelling towards sphere B with a speed of 2 meters per second. We have sphere B of mass 2m, and this is travelling at a speed of 0. And then finally, further on the line, we don't think we're going to have to worry about this one too much until the later part of the question, but we'll put it on anyway. So sphere C is m, which is also not moving. Okay, and then after the collision, we're going to have VA, VB, and to a lesser extent later, this one here, but we're not going to worry about that one too much for now. Okay, so let's form a equation using the conservation of momentum. So conservation of momentum to the right. So at the moment it collides, we'll have 2 lots of 3m plus 0 lots of 2m will equal VA lots of 3m plus VB lots of 2m. Okay, and we'll just tie this up a little bit. So we've got in total 6m equals 3m VA plus 2m VB, and we've got m in every term, so we'll divide 3 by m, so we have 6 equals 3VA plus 2VB. Alright, so as far as we can go with this equation for now. I'm going to call this equation 1. Okay, we also know that during collisions, the coefficient of restitution, or elasticity, is the separation speed over the approach speed. Okay, and in this occasion we know that E is going to be equal to 1. So 1 equals the separation speed. So the separation speed is going to be VB minus VA. VB minus VA, and the approach speed, it was approaching at 2 meters per second, so all over 2. So we can say that multiplied by 2, we've got 2 equals VB minus VA. So let's move VA to the other side, so VB is equal to 2 plus VA. And we can substitute this back into equation 1. So we'll call this equation 2. So sub 2 into 1. So 6 equals 3 VA plus 2 lots of 2 plus VA. And then expanding out, we get 3 VA plus 4 plus 2 VA. And now let's tie this up a little bit. So subtracting 4 from both sides, I have 2 equals 5 VA. So VA equals 2/5 meters per second. And then we can sub VA into 2. So VB equals 2 plus VA. So VB is equal to 2 2/5 meters per second. And that is part I done for question 5. Okay, now for part 2. Okay, now for part 2 we want, in terms of M, the magnitude of the impulse that A exerts on B. So basically we're being asked for the impulse on B. And we know this is going to be the change in momentum of B. So it's a little bit blurry, isn't it? Okay. Okay, so the momentum of B was so it started at 0, so it's just going to be 2m lots of its new speed, which was 2 2/5. So the impulse of B is going to be 4.8 m, and this is going to be to the right. Okay, and we know it's to the right because its overall change in momentum was to the right. So there's our impulse, 4.8 m to the right. And now for part 3. We're being asked to find the coefficient of restitution between B and C after a new collision. So we know that sphere B continues its motion and hits C, and after the collision B continues in the same direction with a speed of 1 meters per second, and C moves with a speed of 2.8 meters per second. So we'll do a new separate diagram here. So sphere B, sphere C, this wasn't moving, and just before the collision it was travelling at 2 2/5 meters per second, and then after the collision we are told that B travels at 1 meters per second and C travels at 2.8 meters per second. Okay, so now we need the coefficient of restitution from this. So we know that E equals the approach speed, the separation speed divided by the approach speed. Okay, so it's separating at 2.8 minus 1, so 1.8 meters per second at the top, and it approaches at 2 2/5 minus 0, so 2 2/5. So nice and simple, you should find that to be 3/4. And that is question 5. Thank you.